Hello everyone, this is Evgeny Chuzhakin. Today I will talk about new application in artificial intelligence, which name is NeoNeuro Data Mining machine learning. NeoNeuro application is a universal artificial intelligence algorithm which solves different tasks like learning elementary math functions, plus, minus, and so on, and learning geometric movements. For instance, it can learn chess movements, chess moves. Also, NeoNeuro solves difficult statistics clusterization tasks and makes it often better than competitors. Here we see how the application solves the task of clusterization in wine dataset. Application shows so-called confusion matrix and error rate is 0 in this case. NeoNeuro is a free application which can be downloaded from an official site as a zip archive. Unzip it and run exe file from a folder. Application doesn't require installation. By default, we see a spreadsheet. Let's look at the first row. Here we see 2 plus 1 equals 3. This is an example how application can be learned addition. We see 4 rows to learn NeoNeuro addition math operation. Let's click on a big button, calculate, and now look at the bottom of the application to the question line. Here we see the same parameters. We can change the parameters in question line. Let us do this. For example, 45 plus 1 equals 46. Application has been learned to add values. The interesting thing that from scratch application has no ability to add. For instance, let us write wrong data. 5 plus 6 equals 78. We understand that 5 plus 6 is not 78. Now press calculate or F5 and NeoNeuro answers I don't know. It means the application doesn't know the answer to the question 45 plus 1. It happened because we gave to the application a wrong line. It means that it was not the real plus case. Let's reload the example. We open the file math.csv. It consists of several examples for plus, minus, and logic operations. I try minus operation. 2. I type minus 2 minus 34 equals minus 32. NeoNeuro can learn logic operations as well. For instance, let us see how it solves XOR operation. So I type 1, press tab, use tab to move to the left cell by cell, like in Excel for instance. Type XOR 0 and answer is 1. Let us try to teach the application from scratch. Click on a new button. Now we see an empty spreadsheet with focus in top left corner. Let's teach the computer to subtract. 5 tab 4 and tab equals 1. Let's begin the second row and type 9, 5, 4. Next line 3, 2, 1. These three instances computer uses to learn subtraction. Below in question line we set the data to check how the program works. Let's try from 10 subtract 5. Type question mark, we can leave empty space as well. Both mean that we do not know the value of the third column and we need to calculate it. We click on a big button calculate or F5. 10 minus 5 equals 5. Let's try 7. 10 minus 7 equals 3. This was the way to teach program to subtract. Now we can save our work to file with CSV extension. CSV can be easily opened in Microsoft Excel or in other spreadsheet applications. Now we will teach the application to make chess moves. We click on New and on a chessboard button. We will see how NeoNeuro learns chess moves. Here on the right side we see piece place where you can select chess piece. It is important that this is just text. Application has no ability to play chess. It learns on base of data in spreadsheet. We click in any place in a chessboard. In white triangle means a field from which we make move, and black triangle means the field to which we make move. The move is valid and we click Save Move. NeoNeuro asks if we need to add matrix for 2D learning. We click Yes and see that new line appeared. The first row in the spreadsheet describes names. The first column is piece name and we see rook in the first line. x1 and y1 are coordinates from which we make move. x2 and y2 mean field where to go. Result is 1. 1 is possible move or valid and 0 is invalid move. When we click on any field and see this empty triangle, application creates 64 question lines to check if we can go to each particular field or not. Look at the bottom of the application to the question line. Rook come from field with coordinates 1 and 1 to the field with coordinates 8 and 1, and answer is 1. It means yes, this move is valid. Let's change the last coordinate, type 5, and we see that the answer is 0. So rook cannot go from 1 1 to 8 5. So this chessboard has no direct connections to the algorithm. It just creates lines for spreadsheet to learn and automatically creates question lines to check the algorithm. Let's make and save another move. And now we see that all the fields are possible to move to. Application thinks like a person. So if we have two different instances and both have the same result, application make a prediction that all the instances have the same result. Now we need to tell the application any kind of move which is not valid. We change this setting, click on Save Move, and here we go. Application can move by rook. Now we select knight and see that knight moves like a rook. Again, application thinks like a human. If something moves like a rook and we have no restrictions to other pieces, maybe all the pieces can move like a rook. In order to get rid of this ability to move like a rook for knight, we need to select these moves and set them to be not valid. And now we add correct moves for a knight piece. Now we see that the knight can go to the fields where real knight should go, and also our knight has a lot of other valid fields to go, which are in fact must not be valid for a real knight. So again, application learns gradually like a human. Finally, application has learned to move like a knight. Select rook. Now we see that rook's moves are not correct, so we continue learning process. We set valid, new valid moves for rook. We select again knight and see what changes appear here after rook learning, and finally we achieve the result when application can go correct by rook and knight. NeoNeuro is provided with a file to learn all chess moves. Let us try a new method. We can just drag and drop this file into the spreadsheet. Now we can go with all the pieces. The moves are correct, and also we have a move of pawn. Pawn move is rather interesting because it is not symmetric. Pawn can go one step forward from all the lines, but from the second line it can also move 2 steps forward. Learning chess moves is an algorithm which can be used to learn any two-dimensional tasks. On the third row of a spreadsheet we see dimension row. Here we can write dimensions x and y, horizontal and vertical. When we make a chess move, we understand that vertical from we make a move and vertical to which we make the move both have the same meaning, the same dimension. NeoNeuro with geometric dimensions can be used for teaching robots to make correct movements. We can teach a robot to clean the house, for instance, but even we can teach a robot to make a surgery. So we tell the robot what movements and actions are right and what are wrong, and robot gradually learns to make a surgery. Use of dimensions in artificial intelligence gives incredible capabilities in a lot of branches we can only imagine. Now come to the next point. NeoNeuro is made to be as convenient as possible. Let's go to Google and open Iris dataset. A lot of sites suggest this dataset. We use the first site. This is the most popular here. And we see this dataset now. And we just copy everything to clipboard. We can press Ctrl A and Ctrl C and go to NeoNeuro application. Iris is a flower. It has three types. Values, numerical values here are measurements of width and height of different types of this flower. This is very easy and convenient to work with such datasets, and in NeoNeuro we just go to the application, click New, close the chessboard and paste it from the clipboard by clicking Paste or Ctrl+C. Now we again click on a big button Calculate, and that's all. Here we see so-called confusion matrix. Let's discuss it in details. In rows we see iris sesota real, iris versicolor real. It means the numbers of this type of iris. Rows mean the real values. For instance, we have 5 instances of iris sesota. Total we have 15 instances. Why? Really we have 150 instances in this dataset, but 10% were get for test and other 90% were used for learning. Test instances marked with green. Click on the result and see the confusion matrix again. Columns show the predicted data. Here the green cells show the right predictions. In this particular case all the predictions are right. Green diagonal shows correct predictions. Let's open another dataset. Iris dataset we copied from the web. We can also copy data just from spreadsheets like from Microsoft Excel. Let's open wine dataset. Now click on the button cross-validation. Cross-validation uses 10% of dataset for test as well, but it continues step by step to use this 10% from 10 different types of all dataset, and finally all data once included to test data, and other parts, other 90% are used always for learning. Cross-validation is a standard way to check data mining and machine learning applications. Let's look at a confusion matrix here. Green cells are correct predictions. Here we see that second class was predicted as a first class 4 times. So this 4 is a number of errors. This confusion matrix is similar to usual confusion matrices which are used in data mining, but here we see some differences. They are: the first, we have unknown answer. This is like a human. If a computer, NeoNeuro, is not confident about the answer, it can answer "I don't know." Another variant is when this application gives optional answer, when a program can say maybe this is a first class or maybe this is a second class. and we see two columns, option and unknown, which shows the number of answers in these types. Error rate is a number of errors divided on a sum of all exact predictions. Here 4 divide 141 plus 4. So here we have 2.76 error rate. This is the most important rate to estimate the quality of data mining algorithm. The nearest plans to improve NeoNeuro Data Mining machine learning application is to add translations to many languages and to add API with examples in C#, C++, and Delphi. If you have any questions about NeoNeuro, please write your questions here in YouTube or to email info@neoneuro.com. Thank you very much for watching this video.